Hi, this is Rick Frederick. Thanks for using this TVS file. Just want to talk a little bit about how to use it, what it's for. Essentially what the TVS test validation summary does, it helps you understand the relationship between true positive rate, false positive rate, base rate, and the proportion of positive scores that you see for a test. Now there's a few parts to this this graph, which is the test validation summary. Down here we see the base rate of the condition. When the base rate is 0, essentially we have nobody with the condition. Any positive test scores seen when the base rate is 0 are by definition false positives. We hope that this value is low. Over here we see the base rate is 1, which means everybody has the condition, and every positive test score seen here will be a true positive, which we hope is high. And part of the basis for choosing a test score is finding the right score at which you minimize false positive rate and maximize the true positive rate. There's always a trade-off. Every time you increase a cutoff score in the direction of having the condition, you're going to increase the true positive rate, but you're also almost surely going to increase the false positive rate. So what is this diagonal line? This diagonal line simply says, as the probability that somebody has the condition increases, the probability of seeing a positive test score increases. Now, that makes perfect sense if the test works validly to identify people with the condition. The line is not at a slope of 1. That would be very nice to have, but perfect tests do not exist. And so generally we're going to see a much flatter slope. Now these two lines here are very important to us. These are the lines that we as clinicians are interested in. So let me start over and say, this is what researchers tell us. Researchers tell us how a test works. This is the probability of getting a positive test score if you have the condition. Well, if you're in the clinic and you administer a test, you don't know what the so-called true state of the person you're testing is, whereas researchers are supposed to know or claim to know. What this line tells us is what's the probability of having the condition if you see a positive test score. So you understand, as a clinician, that's the one we're very interested in, because we can tell without a doubt if the test score is positive or not, given the rules that were set up by the test author or researchers. So we want to know what's the probability that you have the condition if you have a positive test score, and that's called positive predictive power, PPP, positive predictive power. And the other curved line here is negative predictive power. What's the probability that you do not have the condition if your test score is negative? Now these things change. We can come up here and from the research determine what we think is the false positive rate and the true positive rate of the test. So here's a pretty good test. This is a pretty good test. The true positive rate is 80%. 80% of the people who have the condition have a positive test score, and 10% of the people who don't have the condition get a positive test score. So what this file is intended to do is to help you figure out what your positive predictive power is based on your base rate. And you might say, well, I don't know what my base rate is. And I understand. Many folks have not evaluated that yet, and you're not really sure what to do. But let's say you use a test, you give the test to most folks that come into your clinic or or wherever you're testing, folks. Do you know for this classification test, this is a classification test we're talking about, do you know what the true positive rate and false positive rate is? Probably not. Probably you have 10 or 15 articles that have variable rates associated with that, and I have some papers published on how to take that information and turn it into some single values like this. But let's say that you're giving a test and you say, okay, I think that the false positive rate is 10% and the true positive rate is 60%. Okay, so that looks something like this, and you give your test to 100 people, and you find that the proportion of positive test scores is 15%. 15% of the people in your sample have a positive test score. Well, now you can absolutely do that. You can absolutely get that value. And if you'll just come over here, you'll see that the base rate for your condition is now 10%. When somebody in your sample gets a positive test score, when the true positive rate is 60% and the false positive rate is 10%, and the base rate is 10%, the probability that they have the condition is just 40%. Now, if they get a negative score, the probability that they don't have the condition is 95%. Okay, let's do another one. We'll do, let's bring the false positive rate down some. And let's bring this up to 80%. Now, let's once again say, okay, I have 15% positive scores in my sample. Well, with those better values, first of all, we see that your base rate is 13%. If you have a positive score now, in this sample, 70% chance that you have the condition. And if you get a negative score, 97% chance that you don't have the condition. Now, these are the two values that you can change. You really shouldn't be playing around in anything else over here. These are just formulas. If you mess it up, just go back to the website and download the file again. Now let's look over here at a different way of evaluating this. When the true positive rate is 80% and the false positive rate is 5%, let's look at this. Well, let's look at the situation when the base rate is 10%. The base rate is 10%. 1,000 people have the condition. 9,000 people do not have the condition. And if you give the test to all 10,000 people, we expect when the true positive rate is 80%, the false positive rate is what? 5%. Okay, so look. The true positive rate is 80%. Out of the 1,000 people who do have the condition, 800 get a positive score, 200 get a negative score. Those are errors. Out of the 9,000 people who do not have the condition, remember the base rate's 10%. 9,000 people do not have the condition. Notice that 450 of them are classified as positive. The false positive rate is 5%. 8,550 of them are classified correctly. Obviously, green means correct, red means incorrect. What are the implications? Well, $450 errors compared to 800 correct classifications on the positive test scores. Your error rate among positive scores is 36%. 36% of the time, when you have a positive score, you're going to misinterpret it. And down here, this is very nice. Out of 8,750 negative scores, only 200 are in error. And so your error rate is 2.3%. So this is just a little chart to help you. Again, what is the purpose of this? The purpose of this is for you to get to thinking about how you're making decisions in your clinic. What are the implications? The thing that's very exciting to me, of course, is that if you can reasonably estimate this, And if you have given a test sufficient number of times in your clinic, which, I mean, it doesn't have to be a whole lot, but, 30, 40, 50 times would be nice. You can keep collecting that data forever. And then if you can see the proportion of positive scores in your sample, let's say 20% are positive. Here, your base rate's 20%. When you get a positive score, you have an 80% chance of having the condition, having the condition. If you get a negative score, 95% of the time you don't have the condition. So I hope this file is helpful to you. If you have comments on it or questions, please write me at richardfrederick.com, or richardfrederick@yahoo.com. Sorry. Thank you.